All right, let's do this example, an extra example, that this time around, instead of giving us already the mean and the standard deviation of the sample, sort of gives us this data. Okay, so this data represents a random sample of number of home fires started by candles for the past several years. This is from the National Data Protection Association. They ask us to find a 99% confidence interval for the mean number of home fires started by candles each year. So what we can do here, you could grab Google Sheets and just do the mean and the standard deviation using Google Sheets. Very easy. Just put in the data and go ahead and do equals, average, and then of this whole data. I'm just going to do a calculator just because it's easier to do it right here. Okay, so I'm going to go and do really quickly the one variable statistics here for just my one variable. So over here, it gives me my my mean. Okay, you see the X bar is 41.43. Okay, and then my standard deviation is going to be, let's find my standard deviation. So here is my standard deviation. You see this one is S of X, so I'm going to grab that one. This is standard deviation as if this was a population. So these are my two things that I need. Okay, my X bar ended up being 7,041.4, okay, fires. And my standard deviation, my S of the sample, was 1,610.3. And now one last thing that I'm left over with is I need to figure out this critical value, okay, because I do not have how the whole mean distributes, but I do have my standard deviation of the sample, and that's what I'm going to do here. So 99%, let's just see how many years do we have here. 1, 2, 3, 4, 5, 6, 7. So my N is 7. If N is 7, degrees of freedom are going to be one less. So I'm going to be looking at 6 degrees of freedom. 99% confidence interval right here. So the last column, and I need the row of 6. And I'm going to be looking at this number 3.707. So my critical value T, is 3.707. Now, if you remember, in normal distribution, we never saw critical values like that, okay? Why? Because normal distribution really tapers off around 3 standard deviations. And this is almost 4 standard deviations away. So let's really quickly plug in all our information into our little formula. So it's point estimate plus minus the margin of error that is made up of critical value and our standard deviation of the sampling distribution. By the way, if you want to calculate this on the side, you're more than welcome to do that. I do that just to be comfortable for myself. So my S over the square root of N, I had 1610.3 divided by the square root of 7, turns out to be 230.672. I'm not rounded it off yet. I will later on. All right. So my standard deviation, the mean of the sample is 7,041.4. plus minus this 3.707, and then I'm going to multiply this by my standard deviation over here, the 230.672. Okay, so one time I'm subtracting, and if go ahead and figure out what this turns out to be. I ended up with 2,056.2. So one time we're going to do 7,041.4 minus 2256. And one time I'm going to be adding the same thing, and these are going to be the boundaries of my range for my mean fires caused by candles, 2256.2. Okay, so one time I end up with my bottom boundary is 4785.2. Okay, my top boundary for the mean number of fires caused by candles in 9,297.6. Okay, this is kind of a thing that do not light your candles in your house. So, or use LED candles. But there we go. We are going to be 95% confident. I'm sorry, 99% confident. Remember, this was our 99% confidence interval that our true population mean is going to be in this range between 4,700, almost 4,800 fires and almost 9,300 fires caused by candles annually.